Welcome to the Microservice Framework and Overview presentation. For those of you who don't know me, my name is David Edwards, and I've produced this presentation to give an introduction to the Microservice Framework and an explanation as to why it works the way it works, how it works, and all that sort of good stuff. I've been assisted by Justin Cook, who's only going to take over presenting if I lose my voice or something halfway through. We've got about 50 slides to get through, so I'll try and rattle on. But if anybody has any questions on the way through, please stick your hand up and ask, otherwise we'll miss them. So here's a brief outline of the agenda. So first of all, I'm just going to cover off very briefly some of the basic concepts behind why things work the way they work. So first off, to cover those 4 items at the top there: DDD, microservices, CQRS, and event sourcing. Then to move on to a bit more of the detail about our service template and the components that make up a service. And then eventually, on the third point there, getting onto the actual microservice framework itself and digging into a bit of the detail. And then finishing off with a nice long list of do's and don'ts, which will hopefully spur some provocative thought and questioning around why those are the case. So, our first section, just to set the scene. Got a few patterns and principles that we're making use of on the program. The first and the most obvious to everybody on the program will be our domain-driven design approach. I'm not going to explain domain-driven design, but and you can read this slide for yourself. But the important thing is that it gives us a way to talk about the business domain in a consistent way between both technical and non-technical people, and it gives us a way to break up the domain in various ways. The most obvious to technical people on the program will be the fact that we split the business domain up into bounded contexts, which encapsulate a separate part or a subpart of the domain, and then we provide or we implement those bounded contexts through a series of logical services. And the crucial point is that those logical services translate physically into microservices. Those are the physical deliverables that we as developers produce. Another couple of patterns that or approaches that we use on the technical side of things are command query responsibility segregation and event sourcing. So these are 2 commonly combined patterns, and again, I'm not going to explain them in detail, but they give us a few concepts. They give us the concept of commands, which are ways to request the system to change its state. They give us events, which are notifications or a record of state changes. Those are the facts of our system. They record what has happened, what has changed. And we also get the concept of queries, which are our way of querying the current state of the system to find out where we are right now. And if we look back to our domain-driven design, and there's a very good red book, hardback book kicking around in the office that everyone should read, we get the concept of aggregates, which are a way of encapsulating and applying business rules before we change state. So if we think about the microservices that we're building to implement our model, most of them have pretty much identical technical requirements in terms of what they need to do. They all have the same non-functional cross-cutting concerns like access control and auditing. And they all architecturally benefit from the CQRS and event sourcing patterns in terms of supporting our NFRs and our long-term aspirations for how the platform will work technically. So the main difference between most of our microservices is actually the business domain itself. And with that in mind, that means that it's pretty important from an efficiency point of view and to make sure that our technical implementation of all of those microservices is consistent, because it's a lot easier for us as developers to support and maintain and enhance microservices that work in the same way than it is to have to change our mindset every time we flip from one context to another. So that brings us to our service template and the components that make up a service. So we enable that consistency by providing a couple of things as part of the logical architecture. We provide a service template for how each and every service on the program should be constructed, and a clear definition of the components within each of those services with clear responsibilities for each of those components. And because we have both of those things, that means that we're in a position where we can also provide a physical code framework to support building services consistently with a consistent technology stack. And here's what our service template looks like. I'm sure an awful lot of you are familiar with this. I've also drawn it up on the whiteboard over there, just in case people want to remind themselves of this diagram as we go through a few of the later slides. I'm not going to go into the detail of what's on each of those boxes on this slide, but what I want to draw your attention to is firstly the fact that we have three tiers or layers within the service template. We have the API layer at the top, we have the controller layer in the middle, and we have the model layer at the bottom, and a couple of persistent stores underneath that. Then we have three pillars as well. So we have the command pillar on the left-hand side, the event pillar in the middle, and the query pillar on the right-hand side. You'll notice that the names aren't all combinations of those pillars and layers. That's because there were better names for some of them that were more descriptive of actually what they do. So I've also written the names of each of those components in each of the boxes. And in a second we'll go through the following slides which explain the responsibilities of each of those components. And the benefit of being explicit about those responsibilities is that firstly we can be consistent about what each box does, but also it helps us to reason and think about why we're implementing a certain bit of code and therefore what it's trying to achieve by virtue of the fact that we have to decide where it should go in the service template. So first of all, the responsibilities of the top tier, the API layer. So here I'm talking about all three of the top components. These act as a translation and anti-corruption layer. So when I say translation, I mean between clients of the service and our internal representation of what needs to happen based on that particular interaction from that client. So it has a few responsibilities here. The most obvious are validation. So validating that the incoming commands, events or queries are acceptable. So that validation is on two levels. Firstly, we're talking about a syntactic validation. So is the payload of the request adhering to our API, our specification? So if we're posting a JSON payload, for example, is it syntactically valid JSON? But we can go further than that. We can say, does it adhere to our JSON schema? So does it have the correct mandatory fields? Do the fields that it does have adhere to our data types and our patterns that we're expecting for that particular payload? But it can also even go a little bit further, and we can reason about the semantic validation of those incoming requests. So we can say, well, given that this field has this value, is it allowable that that field has that value? So we can go quite a long way to validating incoming messages at this level. We can even validate the existence of referenced data, so we can even go off and check whether something exists somewhere else as well. But crucially, I've called out the fact that we're not talking about business rules here. So we're purely checking that the incoming request is a valid request, not whether it adheres to our business rules, which we'll check further down. The second responsibility of this layer is to implement coarse-grained access control. So the reason why we're talking about coarse-grained control here is because we want it to be fast, we want it to reject requests quickly, and so we want to base it on minimal information. And the minimal level of access control we can provide is to make sure that the user requesting this particular action can actually perform it as a general principle. So if they're issuing a command to add a suspect, is this a type of user that's allowed to add suspects to cases in general? The last responsibility is around auditing, which is a cross-cutting concern. So we need to make sure that all incoming commands and queries and events are audited, so we make sure that we've recorded the fact that a user has made this request to us, even if it's rejected later on. A question?
Coarse-grained control, we have a controller level, not the command API level.
So the question is around coarse-grained versus fine-grained and the layers. So yes, we have two layers of access control, and I'll cover those off a little later. In fact, some of it here. So on the next layer down, the controller layer, I'm talking now not about all four pillars. I'm specifically just talking about the command pillar and the query pillar, because they have common responsibilities. So the first responsibility here is around fine-grained access control. So the difference between the coarse-grained and the fine-grained is crucially that third point on that list, the payload of the action being performed. So the difference is that here we want to get into some domain detail, and we want to be able to check, is this user allowed to perform this particular action on this particular thing? So we can examine the payload, we can go off and find additional information to support the decision, and then make a decision based on that. So that's the difference between coarse-grained and fine-grained, is that the coarse-grained is purely a general question. Is this user essentially in a role that is allowed to do this sort of thing? Whereas the fine-grained is, okay, given the domain, is this user allowed to do this particular thing? The next responsibility is enrichment and transformation of the incoming messages. So for example, incoming commands might need additional information added to the payload that needs to come from another context or another service, for example. We may wish to transform a command or a query for some reason, maybe even because the action failed access control. There are rules around that, which I'll come to a bit later. And lastly, again, we need to audit at this level as well, because if we now fail access control at this layer, then we want to be able to audit and record that fact. So now onto the lowest layer, and the responsibilities for each of these is each of the pillars here is a little bit different. So I've split those out, but they're all on this slide. So we've already passed through our access control and everything else. So the principle is that by the time we get down to this layer, the incoming message or request whether it's a command event or a query, has all the information in it that we need in order to process it. And we've also determined that the user is permitted to perform this particular thing, this particular action. So at this stage, we can assume that everything is there and everything is correct and everything is safe. But now we can perform the final step. So for a command handler, this is possibly the most complicated. This is where we apply our business rules. So we've got our complete command that's come in. We know the user's allowed to perform that command. Now we need to identify whether or not the business rules allow this command, whether the state of the system is correct for this particular command to be applied, and the mechanism we use to do that are our aggregates, and I'll come to explain those in a bit. So once we've decided whether or not we can apply our command based on the business rules, the second responsibility is to raise events and append them to the event stream for that particular stream ID or aggregate. So there are two steps to that. One is that we persist the events into the event store, and the second is that we publish them onto a topic for other parts of the service to listen to. It's worth pointing out at this stage that we're talking about private events here, and I'll come to why I make that distinction in a second. For event listeners in the event pillar at the bottom there, they only have one responsibility, and that's to listen to private events and update the view store. And last of all, on the right-hand side in the query pillar, the sole responsibility of the query view component is to query the view store and extract data from it. So the one I've missed out is in the middle, in the controller layer, in the event pillar, and that's the event processor. And this has two broad responsibilities. One is to transform private events into public events, and the other is to maintain a stateful workflow, which might be triggered by private events or public events or schedulers and that sort of thing.
On the previous slide, why we don't have any close-grain and fine-grain validation. The reason behind why I question is all the boxes are endpoints, right? People can start using Stripe, the controller, or command handler because they're all exposed in REST endpoint.
Okay, so the question there was that why don't we have access control on the bottom layer? So the answer is that everything below, or basically everything on the diagram, is within a trusted area. So we trust all of the incoming requests. So the only endpoints that will be exposed outside of that area of trust will be the API endpoints. So although the endpoints on the controller and the model layers are exposed, they're not exposed externally. They're only exposed internally within the service.
So we blacklist those stuff.
Yeah. So it'll be protected by HA proxy in the firewall like that.
Is that currently in place? That protection at the controller level?
Well, it's not. It's infrastructure. It's not part of the framework. So it depends on the environment. So the last point to note is around state, because in our diagram I've got a couple of databases there, and at the bottom underneath the model layer, and I also mentioned state in the last slide on event processors. So our services are stateless, but they obviously do need to store some state somewhere, and that happens in three places. So first of all, we have the event store, which is a permanent and immutable event-based record of state changes. So whenever we raise a private event within a service, it gets stored in the event store. It never gets changed. It shouldn't get deleted. It also never gets queried directly. We only ever replay events via other mechanisms. and that's partly because the event store is not indexed or anything like that. It's purely supposed to be a stream of events within the database. Second one is the view store. So the view store is a temporary projection of the current state of the system, and it's built entirely from the stream of events that got stored in the view store. Sorry, in the event store. So this is specifically structured for querying, so it has to be indexed to support that, and the data has to be structured and normalized in a way to support that. But because it's built entirely from the event streams that are stored in the event store, it's rebuildable. And that's a crucial and important thing, because the view store has to be rebuildable from the event streams, because there will be situations in which we have to wipe view stores out and rebuild them by replaying events into them. So all of the information in the view store has to have come from private events. And then the last place where state is stored is in the event processor, because that's where we manage business processes like workflows, and therefore that component needs to have a state of where it's got to in a particular business process. So if it needs, for example, to wait for 2 events to happen before something else can happen, then it needs to know that event 1 has happened, and then as soon as event 2 comes in, that can trigger whatever it is that needs to happen next. So now I'm just going to pull out a few other concepts and things that I've mentioned on the way through the presentation so far. The first one is aggregates and events and their relationship. So aggregates and private events specifically, you should consider those as being a standalone Java representation of the domain model. So when I say standalone, I mean that if you took them in isolation, just your aggregate classes and just your event classes, you could look at them and you could examine the business methods that you've written on them and examine the events and the names of them, and you could reason about the domain model based on them. Yeah, there should be a pretty direct mapping between the domain model and the names of everything there. So the business rules that you've written within the aggregates, for example, should be very clear, and they should pretty much make sense to a non-technical person even. And when I say that they are standalone, I also mean that they shouldn't be referencing any other part of the system, part of the service. They shouldn't know anything about commands. They shouldn't know anything about public events. They shouldn't know anything about the service components. They really are just isolated and separate, and they should be, therefore we can reason about them separately. So our model for implementing aggregates is based on 2 aspects. One is the business rules around attempting to change the state of an aggregate or change the state of the system. So we split that logic out within an aggregate so that we can have clear blocks of code that describe the business rules for whether or not a particular command can be applied. And secondly, we split out the actual state changes, or the code that changes the state itself. By that way, we can combine the 2 together in order to implement the business rules and therefore the business model. And a crucial point I've noted down there is that aggregates only need to store the state that is used to check those business rules, because the aggregate code represents business rules. It's not a domain entity that gets stored perpetually or is kept in memory or anything like that to be used again. It's purely a way of controlling those state changes. So if information passes through a stream of events that isn't used for business rule checking, then you don't need to store it in an aggregate. It's of no relevance. You might need to capture it as part of an event, but you don't need to store it in an aggregate. because when we finish processing a command and we've called our business methods on the aggregate, then the aggregate's thrown away.
But raising the business event indicated state change requires communicating with the other components of the framework, right?
No, it shouldn't do. So when we call a business method on an aggregate, we are solely interacting with that aggregate and the events that have been and the events that we might raise afterwards.
The business events you can raise, are they different from private events?
No, when I say events at this point, I'm just purely talking about private events. So yeah,
They are part of private.
yes, indeed.
My understanding was handler raises the events rather than aggregates.
No, the aggregate raises the event. So the aggregate is responsible for raising the events, and in a minute we'll see some example code that shows how it fits together. But it's the aggregate that creates the events. It's the command handler that then stores those events. And that again is because of the fact that we are trying to keep the aggregates and its events as a separate representation of the domain model. Therefore, it shouldn't know anything about how to raise events on topics or queues or anything like that, or how to persist them. It purely knows how to raise events and say, hey, these are the events that happened now that my state has changed. So a few notes on events. Like I said before, events are a representation of state change. So they contain all the information about that state change. They're immutable. Once they've been created, they don't change. And they should always be named in the past tense, because once they've been created and raised, they have happened. So we've talked about two different types of event, public and private. When we talk about private events, they're private in the sense that they are private to this particular bounded context within our domain model. They are persisted to the event store within our service, within our context. And like I say, they must contain all of the data about that state change, because if they don't, then that data is lost forever. Whereas public events are public to all contexts and potentially externally. They're not persisted. They are essentially, you can consider them to be notifications. And because they go outside of our context or outside of the system potentially, they shouldn't contain private data. They should contain notifications that something happened, but that if you want to know the details of what that something was, then you have to look it up. And the reasoning for that is that once we allow an event out of our context, we no longer have the ability to apply access control to it. So if we don't need to expose a piece of information and we want to keep control of access to that piece of information, we shouldn't put it in a public event. Yeah, so there are special case contexts which break some of the rules for specific reasons. The response service within the notification context would be a very good example of that, in that it has to persist public events in order to work. But yeah, that's a good question. Why are public events not persisted? It's because they are raised in response to things happening rather than being raised because the state of the system changed. So if we were to replay our private events, we wouldn't necessarily want our public events to be raised again because they cause things to happen. Whereas private events are a record, the public events are, you could consider them more like notifications that something happened.
So when you say the public events potentially can be public internal, what's the possible example internally?
Sorry, can you repeat the question, please?
Just you say the public events can potentially available to
Yeah.
Can you give an example what
So the obvious example right now is the response service. So if a client needs to know what events occurred on the back of issuing a command, they would subscribe to the response service. And yes, but the client could well be, for example, the UI. So the UI would then receive public events that relate to their interactions with the system. And at the moment, the response service contains no mechanism to filter out information or apply additional access control. It has to assume that all the public events are safe to expose outside the system. It may be that at some point in the future we have to extend the response service to allow a mechanism to support that, but at the moment it views public as public.
It's just for inter-context communication. So one bounded context needs to communicate with another. You can either post the command or you can raise a public event. But that public event is not available outside of the common platform. So
what I mean is
Yeah.
the external party cannot directly access this target.
No.
No, but from a security perspective, it is going externally because when the UI requests events from the response service, it's going to get a copy of the public events. So that is actually external, outside of our security layer, and therefore, in theory, it's exposed from a security perspective. So the next slide, I wanted to talk about eventual consistency because since we've just been talking about events, it's clear that our system is essentially message driven, and pretty much everything past the top layer in each service is going to happen asynchronously. So that means that commands are processed asynchronously. Once we've accepted them in the command API layer, then they get passed down via message queues. So we have no control at that point on when they're actually going to be processed. So the client is just left knowing that the system accepted the command and that at some point in the future it will be processed. Events obviously are published asynchronously. So yeah, even when a command has been processed and it raises a private event, that doesn't necessarily mean that all of the consumers of those events are going to get them straight away. There's going to be a delay there, and possibly even they're going to come out of order. And also the view store is another example where it's going to be updated asynchronously because it can't get updated until the event listener receives the private events. So you can't guarantee when that data is actually going to appear in the database. And so overall, that means that the system is only eventually consistent. And that means that you can't assume that the data that you've pushed in is going to be available to query straight away. It may appear, we can guarantee that it will appear at some point in the future, but we don't guarantee when. We don't even guarantee that nodes of the same service will necessarily have the same data at the same time.
If you have a command which is dependent upon another command result, how are you going to implement that? For example, I execute the command. Based on the command, some result gets output. I want to return some result, and I want to feed that result to another command. How I can do that?
So how can a command cause another command? So I will come to that in a minute. I've got a slide just on that topic. However, there are many mitigation approaches to deal with the eventual consistency of the system. We can, for example, assume that our commands succeed and simply base future work on the data that we sent as part of the commands. We can put data into events and extract the data from the events when we receive them. We can make sure that we don't ever query the system until we absolutely have to. So that's based on not assuming that the data is going to be straight away. We can simply delay querying it out until we absolutely need it. And then we can block on and wait until we get the data back out again that we needed. We can also listen for failure events, which will be part of the business domain model, and initiate remediation for those failures. So exactly what I mean there is dependent on the specific scenario. But for example, if we've issued 2 commands and the second one fails, then we may need to issue a command to reverse the first command, because there's no rollback mechanism there because we're over a transactional boundary. So these are all points on this slide that are very important to take on board and to consider whenever we're splitting up our code across the service components, because we have to take this into consideration.
David, if you're assuming success, why should you listen for failures?
So you assume success until you hear otherwise. So that means, so if you don't assume success, you have to wait until you find out, and then you either block or you're waiting for information back that you already know because you've given it to the system.
Should we not always assume success because we get a 2-2 from what we send command to?
So success, by success I mean that the command was processed and accepted, but the definition of success might depend on your specific use case. So for example, you may issue a command being well aware that one of 2 things might happen. You might get the thing assigned to you, or you might not. So you're expecting that two outcomes might happen. Whereas in other situations, you may be issuing a command with the surety that it's almost guaranteed to succeed unless something really weird is going on. So yeah, the mitigation strategy you use will depend on the specific use case. So the next general principle slide I've got here is around decoupling the context. What's the difference between a command and an event, and how do the contexts communicate between each other? So if you remember, the definition or the difference between a command and event was that a command is a request for the system to change its state, and it may succeed or it may fail. Whereas an event is a record of state change, in that it is something that has happened on the system, and nothing you can do now is going to change the fact that it happened. The best you can do is make another change to the system to do something different. So when you're communicating between contexts, you need to be careful and think about whether you should be issuing a command from one context to another, or whether you should be raising an event and letting another context simply listen for that event. And the point I'm trying to explain here is that with commands, the target that you're issuing the command against knows nothing about the context that is issuing the command. The source of that command is a bit like a black box. It doesn't care where the command is coming from, it just knows that it's been told to do something. Whereas for events, the relationship is the other way around, in that the source that is publishing the event knows nothing about the consumer who's listening for that event and doing something based on it.
So when you say like prior events is always like something happened in the past in a sense, but for public events it's not like that. It's kind of similar.
Well, so the question there was, are public events something that happened? Yes, they are, but they represent something slightly different to private events. But still, public events are things that have happened in the past, and nothing is going to change about whether they happened or not.
But sometimes we use like public events to trigger some command. It's just that command doesn't represent anything.
So yes, we use public events to trigger commands, but they are temporal things that happen once. So once we've triggered that command and that command has been processed and turned into a private event, then the state change of the system has then been recorded for that public event. And at that stage, we no longer care about that public event, and that's why we don't persist them, because we don't want that whole loop to happen again, because once it's happened, we've recorded the result of it happening, which was indirectly via a command. So it's still that it happened, it's just that we now no longer care about it. So I came up with a couple of questions that you could ask when you're wondering whether to issue commands or raise events. The first one is one context telling another one to do something, or is it reacting to what happened in the other context? And another way of looking at it is to think, would this relationship, the solution that you've put in place of this command and event relationship, would it still make sense if you removed one of the contexts? So a good example would be that the structure context, when you create a case, the fact that you can issue a create case command to structure, that still makes sense even if we didn't have the staging context talking to CMS and issuing the create case commands. You know, it may be that we change and some other system issues the create case commands. It still makes sense. Therefore, it should be staging that is driving the process by issuing the commands. Whereas on the other hand, if staging is talking back to CMS and telling it that something on the common platform happened, we want to drive that by raising events on the structure context and listening to them in staging, because if we took staging away, then it would still make sense that we might raise a case created event. Whereas if we'd modeled it by saying that we issue a send CMS message commands to staging, that wouldn't make sense if we got rid of the staging context. So next general concept about messages. So bit of semantics. When we talk about messages, we're talking about commands, queries, and events. They're all types of message. We might consider commands and queries to be a subtype of message, an action. So we might sometimes talk about actions and events, but they're all types of message. A message, whatever type it is, consists of two things. It consists of metadata and it consists of a payload. While it may seem that the payload is the most important part of a message, in actual fact, the metadata is just as important. And I'll explain why on the next slide. When we combine the two together, we talk about a message envelope that combines the metadata and the payload together as a pair. So this is the sort of metadata that we pass around in the system. This is not an exhaustive list, and it may be that certain services or parts of the system or framework may need additional metadata that they will add in. So the system and the framework are all designed to be fairly agnostic about what metadata is in an envelope. But these are the ones that we'll see commonly and are first-class citizens in the metadata world. So the first couple here are an ID and a name. So the ID is a unique UUID that identifies this particular message. So it will be assigned to a message as soon as it hits any surface on a service, if it doesn't already have one. And then the name, sometimes we'll refer to this as the action name. That's a name that describes what this message actually is. So if it was a create case command, then the name might be structure.createCase. If it was a case created event, it might be structure.caseCreated. And then probably the metadata will also have some of these others. So we have a user ID, which is a UUID that uniquely represents the user that issued that action in the first place. It could be a real person user ID, or it could be a system user ID. There may be a session ID if the message was raised as part of a session. Both of those will most likely are most likely added to the message via IDAM. The client correlation ID is an identifier that's provided by the client. The system doesn't care what this is or where it came from. It'll just happily copy it around as part of the metadata. But the client can use this ID in order to correlate what happens to their message afterwards. So if they want to know what happened to a particular command and they want to know that a particular event was raised because of a particular command, they can use that correlation ID that they have supplied to track a message through the system. And last on that list are causation IDs, which are essentially a list of message IDs that led up to this particular message happening. So if an event happens because of a command being issued, then the command message ID would be in the causation list. If you then raised another event on the back of that event, then you would now have a causation list that had 2 items in it: the original command, the event that happened next, and the and so on and so forth.
So in the event fixer, do we have like 3 different identifiers there? Because the one would be from command API, another from the command controller.
No, so long as a message doesn't change as it goes through a service component, then it retains the same ID.
If we change by enriching on the controller level, it will have new probably?
That's debatable. It depends whether the meaning of the message is changed or not. In some cases it will change, because we might actually completely transform an incoming command. Say, for example, it fails fine-grained access control, then we may wish to issue a command to the command handler to say, record this access control failure, in which case that's a different command, and therefore you would want to give it a different ID, and it would have the original command as a causation ID. But that's quite a special case.
Would that not open up the saying that source knows about the target aggregation, that those IDs are coming from the UID from the client, so it knows the source right then?
No, so that's not quite what I mean. So it's purely a record of messages. So it's a wiring thing rather than a domain boundary or sort of context boundary thing.
What about the public events? I mean, all these fields are required for the public events as well?
Yes, they would be. Yeah. Although
You're not persisting, then how the correlation ID makes sense to work within the public event?
well, the correlation ID is critical at that level, because if you raise a public event, you need to know what the client correlation ID was if it was present, so that any listeners can correlate that public event with the fact that it happened because of their original command. So that's a really important one. The causation ID list is crucial for reasoning about the system and identifying why things happened. So we need that as well. Yeah, that goes into logs so that we can debug and track a message through the system. Whether the user ID again would be required, so that you know that it was as a result of this particular user issuing a command or whatever. So
This causation ID, in our program, do we manually set it, or we call some developer message automatically?
So the question was around how do we make sure that causation IDs are correctly recorded. I will cover that off in the on the framework section. That's an important point in that, and that is why I say at the bottom of this slide that metadata is just as important as the payload, and it must be propagated, is because we as developers need to make sure that it is. So we mustn't write code where we break that propagation. We need to ensure that we keep the chain going. So next slide I've got is around the rules of causation, and this comes back to an earlier question around commands causing other commands, and how does that work? So we've got some general rules here. Obviously sometimes rules are made to be broken, but in this case we need a very good reason not to follow these rules, because they allow us to firstly enforce the principles that we've talked about earlier on in this presentation, but also to reason about how a particular bit of code or a particular service component is going to behave. So the important rules that I pulled out here are firstly in the command handler. So commands can cause private events, so that's okay, and we can see how we want to record the result of accepting a command, and we do that by raising public events that then get persisted. But we don't want command handlers to raise public events, because as we've said, that needs to be a one-off thing that we can have separate control over. There may be some situations where we do want to reissue public events, and we don't want to have to run them back through the command handler and re-raise private events. So we need to keep those two concepts separate, and that's why command handlers should never raise public events. Command handlers also should never cause new commands, and the reason for that is around the fact that commands aren't guaranteed to succeed. We need to have a mechanism in place for dealing with failures, and the command handler is stateless, and therefore it can't deal with the fact that the command that it issues might fail, and that it needs that some remediation might need to happen because of that. So all that a command handler can do is raise private events. So how can a command result in another command happening? Well, we need to move that to some other service component, and that'll be the event processor that we'll see at the bottom here. The command controller can transform events or enrich them, but it can't cause events, and it can't cause multiple commands. Can't cause events because we have no way of persisting them from that service component. It doesn't know anything about the event store, and shouldn't do. And it shouldn't cause multiple commands because we have no way of dealing with the transactional boundaries of each of those commands and rolling back or retrying or anything like that. So lastly, the event processor. So we have a rule here that says that private events can cause public events. So this is where we do a translation between private and public. And secondly, both private and public events can cause commands. And the reason why we allow that in this component is because the event processor does have a mechanism for storing its state, and therefore it can deal with failures, and it does know when something's happened and when it's done something, and therefore that it doesn't have to do it again. Does that answer was it your question, Simon? I think, maybe? Okay, maybe you forgot what it was. Oh, okay. Okay, sorry.
Command API is just a simple pass-through, right?
Yes, the command API is the translation and anti-corruption layer. It takes no decisions other than to decide whether or not to accept or reject the command on the boundary of the service. That's right. And the same goes for the query API. It is it's the layer where we accept or reject the query in general terms and translate it into our internal representation of the query.
If we want to issue a generic or a specific audit raised from a controller,
So
issue that.
if can we issue audits from a controller? So audit is a very special cross-cutting concern in that we want it to be consistently applied to the entire program and the entire platform. So it's dealt with at a framework level. So the idea is that the framework supplied audit mechanism should cover all of our audit needs. And if there are specific requirements that aren't covered, then they're probably either not audit really, or they are something that needs to be added across the whole platform.
If you reject command, reject the request in command API, do you still pass 202? Or
No, we wouldn't. So if we reject a command or a query at the API layer, then we'd return a different response code, either a 400 to say that it was a bad request because it didn't pass validation, or a 404 maybe because something wasn't found, or a 403 if it failed access control. So we want to do as much as we can in that sense, in that layer, so that we can return straight away a sensible response code. But there will be some things that get rejected or can't be processed further down, and that presents us with an architectural challenge, because obviously we can't then return a response back directly to the client. So we have, for example, if a command fails fine-grained access control, all we can do is pass a command down to the command handler to say that this happened. In terms of the business model, that's a good thing, because it may well be that we actually need to record the fact that somebody tried to access something that they shouldn't have been able to do as part of that particular part of the domain model.
So you mentioned that event processor can manage your workflow, right? So other than the lifecycle context as of now, do we see any use cases as such?
Consulting goals.
Well, like something like say we got a message coming in that CM01 message comes in, say create a case, right? And then another one comes, duplicate message, right? So is there a place for event processor to handle this? That okay, I've already published such an event, right? And now again the same case has come, so I need not publish that event. So that kind of thing is something we.
Possibly. So the question was, as a general point, was
yeah,
can.
Life cycle is, we can say it's maintaining sort of state of right now.
Yes. So the responsibility of the event processor in any service is exactly the same, which is that it's there to manage process flow. Lifecycle is an example of a context where we need a lot of that, because it is effectively orchestrating a lot of other contexts. But as you say, other contexts could just as easily have a requirement for workflow or process management, and that's the component that it should go into. Essentially, the bottom line is that that's the only place within a service that is able to change state and record state based on events happening, and therefore issue other commands and to deal with the failures of those commands. And therefore any requirement for that sort of process needs to go into the event processor. So yeah, potentially any context might have that sort of thing in it.
Is there any reason why the API to controller model on the command side was made asynchronous and not just from the command handler to over the view store or events? Why is there queues between each of those layers and not just?
So the principle is that it means that it's a separation. It's the point at which you can hand off between synchronous and asynchronous. It's a trade-off. So on one hand, it means that you can hand back to the client and say, yeah, we'll deal with this in due course. But on the other hand, it makes certain aspects of the system harder to implement. But basically, that is the point at which you can start to hand it off and say, okay, we can now deal with this asynchronously. But given that each service as a whole is only eventually consistent, the fact that it is asynchronous from some point is inevitable. So we would have to deal with that in some shape or form. So we want to do that handoff at the most efficient point possible, and that's a sort of balance between providing feedback straight to the client as to whether or not we could accept that request versus doing all of the work before we go back and tell them that we're finished.
So in the CQRS pattern, that having that asynchronous approach isn't to have it between those levels?
No,
It
no,
would be
definitely not.
acceptable to have that as synchronous down to the handler, and if the handler failed, you could have synchronously replied.
Yes, you could have done, but that would have had disadvantages as well. So, like I say, it's a trade-off.
Sorry. It probably helps in scaling if you got too much of messages on the, say, controller layer.
Yeah.
And then you can have another instance of the controller deployed, and it allows you to have.
Yeah.
Synchronous won't allow you to have that kind of.
Exactly. So it does mean that we can split things out and reason about them and scale them separately. The other reason for the split between the layers is around security, in that you can apply different security rules, and therefore you have to break the protocol at some point in order to make that to make that split in the from a security perspective.
You could have had security even if it's synchronous. You could have applied security at those layers even if it's synchronous.
You could have done, but if you've got the protocol split at that level, then you've got the you've got that additional level of security in place in the process. So it serves a few purposes, both good and bad.
Hey David, this event processor hosting public events. So where does it land on the on a different context? So does it land on API or in controller layer?
So the question was, where do public events land when they're raised by the event processor?
Yes.
So the event processor raises public events onto a shared topic that's common to all contexts, called the public event topic. Those can then get listened to by any other context, but the component that is allowed to listen to them is the event processor. The reason for that is that the event listener, which is the only other thing that listens to events, is purely there to update the view store. And it would only update the view store based on private events, because the view store is a projection of the state that's been captured within with the event store. So we don't want public events being propagated into the view store. Therefore, we only listen to public events within the event processor.
So the destination event processor will listen to the public event.
Yes, the event processor listens to public events.
How do we avoid anti-corruption there? So we have it in anti-corruption there in API. So
Yes.
that's an
So the only things that are allowed to raise public events are trusted event processors. So the events that they raise will adhere to the schemas of those events, and therefore we trust them.
I have a question about event processors and listening to public events, especially probably from the lifecycle context perspective. Is there any infrastructural mechanism or mechanism in the framework that actually will prevent multiple copies of lifecycle context processing the public events? Because now I can imagine if we are uploading documents or creating cases, this ends up as public event, and lifecycle context will pick this up. So in case of 5 servers, 5 lifecycle contexts will pick this up, and they will try to create 5 documents and 5 cases.
So the question was, how do we prevent duplicate actions being taken based on public events being received within the same service? Public events and private events are published onto topics, which allow shared subscriptions. So all of the listeners within a event processor or an event listener component that are listening to the same stream of events will be sharing a subscription to that topic. So you can have multiple subscribers to that topic in different services or different components, and each one of those will have its own subscription name, but all of the instances of that particular service will use the same subscription name, and therefore each event will only be received by a single node of that cluster of listeners within that service.
So subscription is shared between multiple instances of the same component?
Yes, it's in JMS2 terms, it's a shared durable subscription. So that also means that if it stops listening for a while, it will when it restarts listening, it will pick up the ones that it missed as well.
I have a question on the controller. The whole controller responsibility is just transform, right? So can I assume this layer is only
No, it's also for enrichment. So, for example, if it needs to add in data that it needs to get from an external service, then the command controller can also add in.
Reference data or something we have to enrich.
Yeah, so for example, it could be that it needs to look something up in reference data and add an additional field into the command, for example. Basically, it needs to add in anything that is required so that the finished command, by the time it hits the command handler, contains all the information that the aggregate needs in order to make a business decision.
Can you put those lines in the presentation as well?
Yes, I can.
So how it fetch the data using the view store of the query API from the second context, right?
Yes, it would do a query out to the. It would do the.
You cannot rely on this.
Well, it's eventually consistent. That's true. It's not straightforward. So when you've got lots of context interacting with each other, then you need to reason about it quite carefully. But yes, you're right. It's not necessarily straightforward to get the information out that you need.
Hard and fast rule that I should do only on controller, or I can do in handler as well. If I need a transformation of little bit there and a little bit of, can I switch between the controller and handler?
So there should be no transformation in the handler itself. By the time the command hits the handler, it should be a complete command that contains everything that the aggregate needs in order to make a business decision.
So logically speaking, handler should not do any query API.
Correct, yes.
That makes sense.
Yeah, indeed. So I think I've got that in my, what are you allowed to do where? Do I have that in there?
By handler level, your communication is immutable. You cannot do anything. You cannot
Yeah.
change, right?
Yeah.
If you want any enrichment, makes sense to do the controller level.
Yeah, absolutely. So controller layer allowed to do enrichment and transformation. Handler layer is only allowed to apply business rules and append private events.
Let me change my code then.
Technical day.
I'll make a note. Right. Okay. Any more? Oh, one more?
When the event process calls the command, that command considered from the top layer like command API or directly handled by the command controller,
It would always issue the command via the command API. Yeah.
like acting as a client.
Yes. Even if it's within the same service.
What happens if the database is unavailable right when the handler is trying to process the data in the store?
So the question was what would happen if the event store was unavailable when we were processing a command? The answer is that it would blow up when it tries to persist the event. That would cause the transaction that it was working in to roll back. The command would not be taken off the queue that it was listening to, and therefore it would be retried again. Then it would be subject to the retry configuration for the broker. If eventually the event store came back up again whilst it was still being retried, then it would eventually succeed. If it gets retried too many times and it fails, then it would drop into the dead letter queue, and it would have to be manually recovered and replayed into the handler again once the problem had been resolved.
Would it go through the API layer back in again, or?
No, it wouldn't. So there's a queue in between the command API and the command controller, and another queue in between the controller and the handler. It would remain on the queue until it had either been rejected too many times or it succeeded.
Access control. Is there any way, or in future, whether when one component from other context try to access another component in another context, should we apply access control between cross-context calls?
Yes, absolutely. Access control applies to all calls into a context.
But
so
they are trusted source. If command controller.
they are trusted, but that doesn't necessarily mean that they can assume that they're allowed to do something, because each context knows the business rules, which are what access control is enforcing, around who's allowed to do what. So it may be that, for example, if a case is sensitive, that even though structure is being controlled by another context, we have to apply the business rules as to whether the original user is allowed to make changes to that case. So we do want access control to fire as though that context was issuing that command as the original user. So we still need to apply the same process to it. There are definitely situations in which we don't want to apply the same rules, but those depend on the specific situation in which we're issuing a command from one context to another. And in those cases, the context would explicitly have to say, I'm issuing this command as a system user rather than as the original human user, and therefore access control can be applied as to whether or not that system user is allowed to perform that action. So you can encapsulate that into the access control rules as well.
Because if there is a fine-grained access control at command control level, and to get the data, it cannot go to the view layer directly. If you use providers, it goes to the query API, and if there is access control at that layer alone,
Yeah, so this is a known issue that's been identified recently, in that you can end up in a cyclic situation. We will address that.
David, one more question. The event store and the view store, they are separate stores, right?
Yes.
Schema-wise. So how do you make consistency? The event is get applied in the right sequence if we use.
Okay, so that's a good question. So how do we ensure that the view store is eventually consistent with the event store? So first off, we never guarantee that it's going to be completely in sync, because it's only eventually consistent. We only guarantee that eventually it will be in a consistent state with the changes in the event store. But in terms of making sure that it gets updated correctly, in terms of message ordering, we have a component within the framework that we can use in order to buffer events so that we apply them to the event store, to the view store in the correct order. So that is necessary because a lot of our events won't allow us to update the view store correctly if they're applied in the wrong order. Theoretically, it's possible for us to design our events so that they can be applied in any order, and that would be the ideal scenario, because then we could just replay the events into the view store as fast as we wanted, and it wouldn't matter what order they came in. The view store would just be eventually consistent. But as it stands, most of our domain events, our private events, are dependent on order, and therefore we do need to make sure that they get applied in the correct order. And like I say, we have a buffer in place in the framework that keeps track of what it's expecting, and will buffer up events if it's missed one and wait for it to come in. So the order number is the version number within the event stream, and that is managed as part of the events store. It's there by default as part of the framework in the event listener. Yeah.
Does the eventual consistency of the framework have implications on the audit? When will things be appearing in audit?
So I guess yes, the audit service is eventually consistent as well. It's treated as a special case, separate to everything else. So we have a separate queue that we record audits log events into, and they're streamed into a separate service that then simply just records them. But yes, that's eventually consistent too.
I'm just wondering, what is the definition of eventually? How long is that standard?
Well,
how long is a piece of string?
So performance testing has not been done on the full end-to-end process in Anger. So how long it actually takes for something to be persisted all the way through into the view store, I don't know the answer on production hardware. I would hope that it's pretty quick. However, the question around what's the eventual consistency of the entire system is a separate issue, because of course an event might trigger a cascade of other business actions as part of the business processes, and those might take time to finish rattling through the system. So actually issuing one command might mean that the system as a whole doesn't settle down and stop doing anything and be at rest for minutes, hours, or days, depending on the business processes in place. So.
No SLA with business. Is there no SLA with business? When usually they have a business?
I don't think that there's a hard and fast number on eventual consistency. In fact, I'm not even sure if there is one on response times either.
It's 2 seconds.
2 seconds, is it?
Sorry.
Right. But there's a very distinct difference between the SLA on the responsiveness of the system versus the eventual consistency of the system, because on the one hand, the eventual consistency in many cases is irrelevant to the user experience, whereas in other cases it's entirely relevant. So it depends on the part of the system that we're talking about.
Is it worth moving on to the next section?
Yeah, we should.
You only got about 40 minutes left.
Okay, right. I will carry on because we haven't actually got to the framework part yet. So, so far we've kind of just talked about concepts, even when we've been talking about quite specific use cases and rules and so on. We've still been talking, generally speaking, logically rather than about the actual implementation of the framework and the implementation of the business logic. So this next section goes over specifics. I haven't made this code heavy, although I could have done. But I think that that's a lot easier to do in your own time by actually looking at the code within the framework. I'll just cover off a few concepts. Oh dear, going backwards now. A few concepts around why the framework is how it is. So first of all, we've talked about why it's important to make all of our services consistent. It's so that we can reason about them and we can work across multiple services as developers without having a mindset change from one place to another. Secondly, we want to try and separate out the plumbing within a service from the business logic, so that we can, once we understand how the framework works, we can just focus on the business logic and doing a really good job of implementing our domain model in code. The second 2 points are kind of connected. The framework is built on the principle of providing composable components that have very strong opinions on how things should be and how they should be used. But on the other hand, because we compose them together rather than enforcing them to be used in a certain way, it gives us the flexibility to deal with special cases and reuse the components in different ways where we need to. From a technical perspective, the program decision was on using the JE7 API, so we use those standards wherever we can. That also means that from the perspective of the framework components, we use JE dependency injection to inject those in and wire them all up. The last principle that we built the framework on was around doing code generation at build time. So there are an awful lot of parts of our services that we can generate automatically. So reduce the amount of code that developers need to write. We decided to rather than do that at runtime, to do it at build time, so that when we come to compile the project, we've actually got generated classes of code that you can look at. You can see exactly what they do, and you can, when you come to run your service, you can step through them, you can debug them, and you can see very explicitly exactly what's going on in your service. So those are the principles. The last principle is that the framework is open source. If you don't know already, it is on GitHub, and it's available for anybody to go and look at. It's also available for anybody to contribute to, and we actively encourage people to do that. TechPod is not the owner of the framework with the custodians, if you like. It would be great if we had more people who were contributing changes, enhancements, bug fixes, tests, whatever else to the framework. So please do that. If you see any piece of code that is reusable, for example, anything that you think would benefit other people, or a feature that's not yet available, then we're well open to contributions. But please do discuss them with us beforehand, so that we're going down the same path in terms of how we want things to work. And also, please follow our coding guidelines that are also up on GitHub. So, we've talked about the service template and how it splits up into service components. Each of those service components largely follows the same pattern, and this is the ports and adapters architecture pattern, also the hexagonal architecture pattern. So this slide shows my irregular hexagon of what a service component looks like. Those two are in the wrong order, sorry. This is generically what a service component looks like. Messages come in through an adapter, which is what translates between the outside world, whether it's REST or a JMS message, and our inside world, where we want to deal with messages regardless of where they came from in the same way. So an adapter's responsibility is to do that conversion. So if it comes in via REST, via JAX-RS, then we want to take the information out of that request and turn it into our internal representation of what a message envelope looks like. So getting all the metadata out from the headers, combining it with whatever else we need to, and setting that up, taking the payload out of the post body, for example, and shoving it into the payload of the envelope, so that when we come out of the adapter, we then have a single representation of what a message is, regardless of where it came from or what it was originally. We can then push that message through the framework in a consistent way. So we then have this concept of an interceptor chain, which can apply fixed steps of processing that message, or rules to that message as it comes through. And then finally, when we've finished going through that chain, we can pass the message on to a dispatcher, which can pass it off to a business logic handler. The handlers can have components injected into them it can then perform whatever logic it needs to in order to fulfill its purpose, and then it's done. So our concrete example here just fills in a few of the blanks. So for example, if we're issuing a command, then that would come through a REST adapter because it's a REST request. We would probably put that through access control next in the interceptor chain. Maybe we're auditing it as well at this stage, so it has to be automatically audited. Then finally, the dispatcher can go away and find the right handler to pass it on to. In this case, now we're talking about a command handler, so maybe that needs to get the stream of events for that particular recipe, run it through the aggregate, rehydrate the aggregate, apply business rules, and then append some more events onto the event stream that we then need to persist and publish. So we have this general pattern for what a service component should look like. How do we enforce that or support using that pattern? So we have a lot of Maven configuration to do this. So first of all, we have a service parent POM that we use as the parent for any service. And what that does is it enforces the dependency management via a series of bombs to make sure that everyone's using the same version of everything. Enforces various Maven rules on what you're allowed to change, version conflicts, all that sort of stuff. And it also provides a whole load of standard plugin configuration for things like ensuring that we're always compiling to Java 8 or things like that, but also things that are specific to services around code generation that I'll cover off in a second. We also have a series of component POMs which control the dependencies for individual service components. So there's a command API POM, for example, that when you depend on it within that particular service component, it gives you all of the standard framework dependencies that that particular component needs, and it also gives you the ones that are specific to that. So that's how we enforce that a command handler gets to know about the event store, but a command API component doesn't. So going through some of those components within the framework, starting at the top, talking about adapters. So we define, we write RAML to describe all of our APIs. So for our REST APIs, we write standard RAML that follows a certain set of conventions that are specific to the program. But we also use a RAML-like syntax for describing messaging APIs as well, that we've been calling MAML, which basically just uses the base URI as the name of the topic that you're listening to, and then represents the messages that you consume as post requests and the messages that you emit as get requests. So that means that we have a definition within our RAML of all of the message types, whether they're commands, events or queries that a service component consumes, and also if it emits events, then also we have RAML that describes that as well. And because we've got the RAML in each of these service components for what we consume and what we emit, that means that the framework can then generate adapters for all incoming and outgoing messages. And that uses the RAML Maven plugin that we've written. So first off, we have configuration in the service parent POM that packages the RAML into a separate jar file so that it can be used independently of the code. Then we have plugin configuration for our RAML Maven plugin that allows us to, that automatically will generate code for adapters and clients for both REST endpoints and messaging endpoints. The plugin can pick up local RAML files that you've got in your source RAML folder, but it can also pick up RAML from Maven dependencies as well. And this is what allows us to depend on another context's RAML for its API, and therefore generate client adapters that can talk to that remote endpoint. So all of the adapters, therefore, that get covered off automatically as generated code from the RAML. An exception to that would be where we're not talking standard REST supported by the framework. An example would be staging, talking SOAP to CMS, where that particular service needs a custom adapter to handle that. And there may be other cases of that in the future as well.
I have a quick question about how the messaging adapter is generated from the messaging RAML.
Okay.
We don't specify the actions name there. So how does it know that for this particular JSON payload, it needs to invoke this particular action? Does it do some kind of class path scanning to generate adapters? Or how I can glue the code together?
So all of the wiring up between adapters and handlers and RAML is all based on the action name.
Yes, but the action name is not there for the messaging RAML.
So the messaging RAML does have the media type for the messages that it receives, and that's where we get the action name from.
So it's like convention, because so we have got this vnd.staging.command.preCharge, for example, something, and for example the method is annotated with handles staging command preCharge decision request received.
Yes.
So I guess this is like a convention.
Yes, it is based on convention. Yeah. So the media type of the messages that are incoming needs to match up with the action for messaging RAML. For REST RAML, the rules are more relaxed to allow us to build more RESTful endpoints. So we therefore have a mapping within the RAML that allows us to specify a different media type and then say in the RAML that this maps to a particular action. Whereas in the messaging RAML, we don't need that because there's a very fixed relationship between message type coming in and a handler that it needs to be passed on to. So yes, that's based on convention.
So why we cannot keep same for both, for HTTP and for messaging, get it from the media type?
So
I have to remove two things, right?
the reasoning there is that for messaging, we don't need to enforce the additional step of providing a mapping because that would just be extra work that we have to do for every single message type. And people would have to remember to do it and cut and paste the additional code in every time. Whereas for the REST endpoints, those are much more likely to deviate between the action and the media type. In fact, in the future, we'd like to encourage it more that there should be a difference so that we can write more RESTful endpoints and have that mapping. For the query side of a service, it's crucial that there's a mapping because the media type on the query side refers to the response type to a query rather than the incoming query. So we have to have a mapping that says that a particular endpoint maps to a particular action because otherwise we wouldn't know what it was. So the next step down in my diagram of a service component was the interceptor chain. So we have this mechanism to allow us to hook in cross-cutting concerns, such as access control and audit, but also to hook in component-specific interceptors, such as the event buffer. You probably can't see the detail on that picture, but it is on Confluence. Basically, this is similar to the servlet filter chain design in that once the request comes in and starts being processed, it gets handed off to an interceptor chain, which knows about what interceptors the message needs to pass through. Then each interceptor within the chain looks at the message, decides what to do with it. If it's finished intercepting on the way in, it passes it on to be processed by the chain, which then decides which interceptor to pass it on to next, and so on all the way down to the bottom of the chain, at which point it's passed on to the dispatcher to dispatch to a handler. And then once we get the response back, it passes back up through the chain with each interceptor doing something to it on the way back out if it needs to. So it's possible to hook in additional interceptors simply by annotating them and providing them with a priority to appear in the chain. But generally speaking, the interceptors should only be used for, like I say, cross-cutting concerns and specific framework or plumbing related things rather than to business logic related code.
Yeah, but do we need authorization interceptor chain for asynchronous communication?
So do we need the interceptor chain for both asynchronous and synchronous? Yes. So it works effectively. It works exactly the same for synchronous and asynchronous. Because although we might not actually be returning a response back from the handler at the bottom of the chain, we may well need to do something based on what has happened rather than before it's happened. An example might be audit, for example, or access control. We may need to, at some point in the future, apply access controls on the way out, or after something's happened. We may need to also audit things after they've happened. So at the bottom of the interceptor chain was the dispatcher. This slide's really here just to get the naming in of the components. So we dispatch in the dispatcher to a handler. The lookup, as we've mentioned just earlier, is based on the action name, which is the string that we use to link everything together. And we also use that action name within the handles annotation to indicate which method handles which action. As an aside, it's worth noting that the framework also uses a dispatcher mechanism for outgoing messages as well. And when it does that, it generates handlers from the RAML for calling remote services. So it uses exactly the same mechanism for that. So it's nice and generic. So a handler is the unit that we use for decoupling the business logic from the framework. It's the point at which we pass control from the framework into the business code. So, as I said before, we use the handles annotation to hook the two up. So we then pass in the message as an envelope, as a JSON envelope. This is a contrived example, incidentally. It's not real code. We pass it into the message into the handler as an envelope. We can then use injected framework components within the handler to then compose our business logic to do whatever we need to do. So in this case, we've got an example of a command handler, and what it's doing is it's taking the incoming command, it's finding out what the stream ID was from it, it's getting an event stream from the event source component, it's then rehydrating an aggregate from using the aggregate service, and then it's calling a business method on our aggregate to add the recipe, getting back the stream of events from the aggregate and appending those onto the event stream so they get persisted and published. This is a good example of what I mean by composable framework components, in that the event source knows nothing about the aggregate service knows nothing about the event source, and the event stream knows nothing about the aggregate. So the responsibility of the handler here is to compose all of those different things together and orchestrate them and tell them what to do. We don't impose that wiring up because we need these to be flexible about how they can make use of the framework components.
It would be nice to annotate the class also with combine.
Yes, that's true. I've tried to make it as simple as possible to try and represent certain concepts. So I'm now going to go through a few of the different framework components that you can inject into a handler. One of the most obvious are senders and requesters. They are framework components that allow you to send messages to other components or other services in other contexts. The difference is really whether or not they expect a response back or not. So senders are asynchronous, they're fire and forget, typically for commands or events, whereas requesters expect a response, and they're typically used for queries. In the future that may change, but that's how it is at the moment.
Senders do expect 202 though?
Yes. If they don't get a 202 back, then they will blow up. So they're injectable. For both of them, their destinations are generated from the RAML. So they're pretty magic from a handler perspective, in that if you create a message to send or a query to make a request, all you have to do is specify the action name of the message that you're sending, and the framework behind the scenes will work out from that where that message needs to go. And the way that it works it out is based on code that it's generated from your RAML. It's also worth tying back to your point around the service component, in that a requester or a sender is also tied to a service component. So when you inject one into a handler class, it only knows about the destinations that are specified for that particular service component. So there's a separation there, so that each service component only knows about what it's supposed to know about.
What are the transaction boundaries? When you talk about handlers, we have senders, we have the requesters, senders sending to some asynchronous communication, right? So what are the transaction boundaries, like, when I handling
The transaction boundaries.
yeah,
So the transaction boundary is around your service. So, well, more specifically around your service component. So if you're sending a command to another context, for example, then the transaction is, did we manage to get it onto the queue or not? If we got it onto the queue, that's the boundary of our transaction within that within our code.
what is the order? First we cover JMS and then Postgres, or
So the transaction will also include any database reads and writes as well. So yeah, so if we're doing both, so if we're writing to the database and we're sending a message, then the transaction is XA. Yeah, it's across both of them. So they'll both roll back if one of them fails. Yes. So another injectable component we just saw was the event source. So the event source is a service for retrieving event streams, specifically by stream ID. You would typically get the stream ID from the incoming command. So it might be the ID of the particular business thing that you're applying your command to. So in our case, just back then, it was the recipe ID. But there are special cases where you might have a fixed stream ID because all of your incoming commands raise events against the same stream. An event stream is a class within the framework. It's a wrapper for a stream of events. Once you've got that wrapper, you can then read it. So you can either read from the start or from a specific point in it, and you can append to it. When you append to it, we implement optimistic locking using version numbers. So if you don't specify a version number in your event that you're appending, then it will assume that you wanted to append it onto the end of the stream that you got originally from your event source. So the optimistic locking will kick in if anything else appended an event to your event stream in the meantime. So that means that we can guarantee that once you've got the event stream, if somebody else appends to it before you get to append to it, that we will throw an exception that you can handle if you need to. If you don't handle it, it'll bubble up and your whole command will get retried. If you do catch it, then you can try and deal with the problem within the handler if you want to. It also supports explicit version checking. So if you do want to specify a version, you can explicitly append after a particular point in the stream. So you can say, okay, I'm only interested in this succeeding if the stream is currently on version 10 and I'm appending event number 11. And so you can explicitly say that, and that allows you to implement your own locking in the sense that you can make it so that commands have a version number in them that will say what version of the aggregate they expect to be applied to, and therefore you can enforce your own checks in your sequence yourselves. It exposes the events as Java streams, and behind the scenes, when you append to the event stream, it will persist to the database and publish them automatically for you. So, aggregates. We've talked briefly about conceptual boundaries for aggregates. From a code point of view, every aggregate must implement the aggregate interface. That allows us to make a distinction between business methods that assert business rules and create new events, and keep those separate from the actual state changes to the aggregate that we keep in a separate method called apply. So it's worth knowing that that those business methods that assert the rules also needs to apply their own events, otherwise they will leave their aggregate in an inconsistent state, which in a lot of cases probably doesn't matter. But if you ever assume that the aggregate that you've just updated with one business method is updated when you call another business method within the same block of code, then obviously that would start to become a problem. Business methods also shouldn't know about commands, and this comes back to our separation that I talked about right at the start, that the aggregates and the events are an isolated standalone representation of the domain model, and commands are not part of that. The commands are part of the handling flow up to that point, and the command handler acts as the translation between the command and the aggregate. It's okay. So here's an example of what I mean. So this is a recipe aggregate. It's incomplete, and it's just to demonstrate the concepts. So the aggregate interface that it implements insists that it implements an apply method that takes an event. We have some Fluent helper functions that you can see in the apply method that allow you to match on events and perform state changes. So in this case, we're saying that when we see a recipe removed event, that we're going to wipe out the recipe ID, and when we see a recipe added event, we're going to set the recipe ID. And that means that in the business method above, the remove recipe method, we can reason about the current state of the aggregate, and we can say, okay, if the recipe ID equals null, then we'll just ignore this request to remove the recipe because it's already been removed, so there's nothing to do. Whereas if it has been set, then we need to issue a new event to say that the recipe has been removed, specifying the recipe ID. So to reiterate, the bit in the remove recipe is the business rule that we're implementing, which says we only issue a recipe removed event once in the life cycle of a recipe. That event is the command to remove a recipe is idempotent, so we can issue it again and there's no change. And then the actual state changes themselves are put into the apply method. And the reason for that is so that we can apply those state changes independently of applying the business rules. And that's important when we want to rehydrate an aggregate from an existing stream of events. And that is what the aggregate service does. So it takes an event stream, you tell it what aggregate class you want to rehydrate, and it will run through the event stream and reapply all of the events in the event stream to the aggregate, bringing it back into the state that it was in after the last event that was in the event stream. And that gives you back an aggregate that you can then call new business methods on to decide whether or not to apply new commands. We also in the framework have a snapshot service, which is not designed to be used directly by business code. It works behind the scenes with the aggregate service in order to take snapshots of aggregates. Because if the event stream is getting very large, then replaying the event stream through the aggregate every time we want to apply a new command will become a very heavy operation. So the snapshot service allows us to keep copies of the aggregate at certain versions so that we can only replay events that happened since that version.
About snapshot service, if I'm using aggregate and there's a snapshot in particular version, but I'm trying to update the same without using aggregate service. I'm just updating by raising some events.
Yeah.
Because it does not have any business logic. So now when I replay back, how does this events which I have raised without aggregate service is associated?
So that would circumvent the snapshot system if you weren't using the aggregate service. It would still technically work in the sense that the snapshot service knows that it has a snapshot of an aggregate at a certain version. So whenever you asked for that aggregate back from the aggregate service, it would look for a snapshot, see that it was out of date and that there were new events that you'd appended directly, and it would replay those. So it would give you back a correct aggregate. So it'd still work. It's just that any events that you append directly to the event stream wouldn't trigger a new snapshot being taken. So you'd end up with your snapshot not getting updated as regularly as you would otherwise have it updated.
Is it recommended?
Not really. I think if once you've got an aggregate, it's sensible to put all of your events and all of your business rules going through the aggregate.
But if I'm updating something that does not require the business logic.
Well, you'd still need the aggregate to be aware of that event, so you probably have to make some changes to the aggregate because otherwise it's not going to know what to do when it hits that event in the event stream. So you would at the very least have to update your aggregates to handle that event as it goes through. But I guess it's a judgment call. So the strategy for deciding when to take snapshots is configurable via an injectable class. Behind the scenes, it uses Java serialization. It's critical that as a developer you're aware of the fact that changes to your aggregate may result in a class that on a subsequent release is not compatible with snapshots that we have in the system. So we have to make sure that as developers we update the serial version ID whenever we make a breaking change to the aggregate.
Can we take in-flight transition as a right use case for the snapshot service? Because maybe you have some in-flight events which works pretty well on a previous snapshot version, and then you will have a reason to apply the snapshot service.
So question around in-flight
Some
events
in-flight
and
events
if
sitting on the queue, new release happened, and now we have some in-flight events which works pretty well with the last aggregate.
so dealing with releases for in-flight messages is still an open question that we don't have a standard approach to across the platform. The initial approach to dealing with that sort of situation is shutter the service and stop processing everything, release the code, and then start processing again. But again, it's a valid question in terms of backwards compatibility, and it's a general principle that as developers we have to be aware of the fact that the system is asynchronous, message-driven, eventually consistent, and and therefore any code change that we make has to either be backwards compatible with things that are already out there in the wild. So you can't just make a change to an event and all the code surrounding it and expect the system to carry on working. Once we're in production, then we have to deal with the fact that there are old versions of events out there, old versions of the code out there. So we have to take that into account when we're making changes. We need to be aware of the fact that it's possible to make breaking changes, and if we do make breaking changes, we have to mitigate that as part of our strategy for releasing. So we have to be explicit about it. If we make a breaking change to an event, we have to be explicit about that and say that it's a new type of event with a new name for that event. We have to make sure that our aggregates are backwards compatible with the old events that will still be in the event stream, as well as in flight. So it's a big deal, and we need to think about that when we make breaking changes. So support for envelopes in the framework. I mentioned right at the start around propagation of metadata. It's critical that we do that, and we have a framework component called the enveloper, which should always be used to create new envelopes within your code. It forms the service of copying all the metadata from the source envelope, wraps up your payload, assigns the new envelope a new message ID, and also makes sure that the causation list is updated as well. So it does all of that for you. There's no reason to ever create an envelope any other way. Access control. I think we've kind of covered off the first half of this already. Coarse-grained and fine-grained, i.e. fine-grained is allowed to look at specific business domain questions around whether this user should be allowed to do this specific command. And the examples here are they a defendant on this particular case? Is this particular case flagged as sensitive? That sort of thing. Whereas coarse-grained would simply just check, is this user allowed to do this sort of thing to cases in general? Currently, our implementation of access control uses Drools rules, which are packaged along with the business services themselves. At some point in the future, that will change, and we will probably move access control into its own service and its own context. But this is how it works for now, for simplicity. So the Drools rules have access to the action being performed and the metadata associated with action, so they'll know who the user is that's performing that action and what it is, and they have access to the payload. They may also need additional information from other services or other places in the same context. They can use providers for doing that. So we have a concept of a provider component which is made available to the access control system using annotations. the access control is automatically executed by the framework as an interceptor. So it will have happened before a message hits your handler automatically in the correct component. Framework support for persistence. So as a general principle, we use JPA for all of our persistence. It can be done using straightforward JDBC repositories where we write all the queries. That's the most efficient and simplest way of dealing with simple cases and code where there isn't too much complexity to the SQL. But where we need to, in the view stores, for example, we may want to use full-blown ORM, define JPA entities, and do it all that way. However, we should approach that with caution because it's not actually strictly necessary. Because it's a stateless system, anything that we do with entities is temporal. We're simply using them to get the data out into Java objects to simply push the information back out as JSON. So in a lot of cases they're overhead, and we need to be careful about our referential integrity, because view stores need to be tolerant of message ordering and faults. So views are not the system of record, they're a projection of the event store. The event listener listens to events and updates the view store. If the message listener throws an exception when it receives an event, it's going to blow up. In fact, it's going to stop processing completely, because we have to have the event buffer in place to order the events coming in. As soon as it fails to process an event, it's going to stop and wait for somebody to fix it before it carries on, because it has no idea how to deal with that inconsistency. And one of the situations in which it is probably, and this is part of the feral exceptions work, one of the situations in which it's likely to throw an exception is if there's a primary key or a foreign key constraint violation. The only reason why we have those primary keys and foreign key constraints in there is because you guys have put them there. They may well not be performing any sensible or useful constraint on the system, simply because the events that we're running into the view store have already happened, and there's nothing we can do about it. So to prevent the view store from being updated based on the fact that we didn't believe the event stream is a false decision. What we actually need to do is store the information that we've been told to store and deal with the inconsistency on the view query side of it instead. So, for example, if we're told to add a suspect and we don't have a suspect ID in the database already, then we need to just persist the information we're given, and maybe we exclude that suspect when we query that particular case, for example. Otherwise, everything dies.
So I'm sorry, is there a reason then that we're using a relational database to store these things when, because that's the power of a relational store, that it lets you build indexes and foreign keys and foreign keys and links to put things together. So is the plan to shift away from that?
Potentially, yes, that's a good question. So if we're not using the facilities of a relational database store, then why are we using one in the first place? Part of the reason, I would say, is probably convention, in that everyone understands how to talk to a database and query it. So it's easy for people to get started with it. And secondly, I guess there are complications that are introduced by trying to add another technology to the program, particularly at this stage. So personally, I don't see any reason why in the future we should continue doing that if we see a benefit from moving to a different type of data store. So the other points to note on JPA is that we also have support for Delta Spike. So Delta Spike has a library that works a lot like Spring Data, in that you can simplify a lot of common repository patterns simply by convention of your repository interface. So that can be used where necessary. We also have some test utils to support that. And also test utils to support testing of JPA repositories and entities as well. So we can do unit tests on those. Our database schemas should be versioned using Liquibase. Liquibase scripts are a way of managing schema changes via a log of change sets. When we make a change to a schema, it should be done by adding a new change set to the log of changes. We should never change an existing change set because if we do, when you try to apply that change log to production, for example, then it just won't work, it will stop. So if you want to add a column to a table that already exists, you don't go back and change the create table statement in the Liquibase change log. You add a new change set that says add a column to this table instead.
Quick question. So we don't like use key for is it advisable we maybe like an index like a primary key forum column because this is for performance.
Absolutely. So question was, if you don't have a primary key, should you have an index instead? Probably yes. So indexes should be part of the of your Liquibase schema updates to add indexes where required for performance purposes, and we should do that as part of designing the database schema.
Sorry, can I just add one more thing about the Liquibase stuff? At the moment, it probably doesn't matter as much because we haven't got a running system and no data in it. But we have to be really careful when we change the structural shape of the view store, and we are making sure that the data that was there gets transferred into the new constructor shape that you're planning to do. Unless there is paths, then whenever we do an update, then we replay all the events we use schema.
Yes, absolutely. So right now, whilst we're developing and we're not live, then we have certain flexibility over the changes that we make to our schemas. And my previous rule about changing change sets doesn't apply necessarily to whilst you're still developing, you haven't committed, and potentially with discussion with your development team, you could even make changes to change sets before you actually get your schema into the dev environment, for example. But yeah, once we are in production, we have to be very careful about schema changes to make sure that they either keep the data that's there already, or that as part of the release plan for that particular release, we are aware and have put in place a process for rebuilding the event store. And that is part of the overall architectural pattern. It's not that that's a bad thing. There will definitely be times in the future where we have to rebuild view stores. That's why we have to make them so that they can be rebuilt from the private event streams. So we have on the TechPod roadmap a project to build a replay tool to simplify the process of replaying events into the view store. And at that stage, we'll have a scriptable approach to wiping a view store database, running events back into it, and rebuilding it. So that would be the approach to dealing with significant schema changes. So there would be a release process for doing that.
Would you also potentially just build a new view and deprecate the old one?
Yes, so there are lots of approaches to take for sure. With a mind to backwards compatibility yet again, we need to be aware of this. So yes, it would be another way would be that you build a separate view store with separate queries, you replay events into that view store, and then, like you say, deprecate the old one and get rid of it once you no longer need it.
None of our Liquibase has rollback this thing. So usually, if you have to roll back a script release or something, you can use that. Do you think that is something we should have, or is fine?
Yes, absolutely. Best practice would be always test your Liquibase change sets to make sure that you can roll them back as well. I would assume as a developer that whilst I'm developing a change set, that I would take the existing database and I would apply the update and roll it back and apply it again before I committed it, definitely.
Most of our scripts are rollback. We are able to roll back them because if you are adding columns or like creating tables and stuff like that, Liquibase creates rollback scripts by default.
The-
But something like inserting or something like that, that's not supported by default.
Yeah, so so Liquibase has some auto rollback support. There are some operations that it can automatically figure out the rollback for. Other things you have to manually add in. But until you, it can be a bit surprising sometimes. Sometimes you assume that it would be able to do it automatically and it can't. And it's not obvious until you try it. So definitely worth testing. There will occasionally in the future be situations where it's actually impractical to write a rollback for it. And in terms of release process, it may well be that we have to have some other kind of mitigating process for rolling back that particular release. But that's going to be on a case-by-case basis, I would imagine. Okay, moving on. Last thing here is test utils. So as part of the framework, we have a whole suite of utilities to support common testing scenarios, including builders for quickly constructing envelopes as part of tests. We have the service components tester for validating service components. We have clients for doing for polling REST endpoints for waiting for responses as part of a test. We've also got recently we added a schema validation matcher so that you can do assertions on your on JSON schemas as part of your test to test your schemas, and there's a whole load more. And if you guys contribute new changes and identify code that you're cutting and pasting between contexts, for example, roll them up into reusable libraries, then I'm sure that the test util suite will become massive by the time we go live. So please, this is a big area for contributions. You should never be rewriting the same test util in more than one context. So, on that note, the last part of the presentation is a big long list of do's and don'ts. So I'm going to rattle through these as fast as I can, trying to justify each one as I go along. If anyone wants me to pause and disagrees with any of them or wants to ask for clarification, stick your hand up and I'll stop. Otherwise, I'll, with a view on time, I'll try and go through them quickly. So, commands, events, and aggregates. These are the do's. Command names should always be in the imperative mood. They should always tell the system to do something. So, create case, update task, assign, things like that. We're always telling the system to do something. Whereas event should always be named in the past tense. Case created, assignment, assigned, for example. We should consider aggregates as decision points or business rules which have a transactional boundary, in that everything that you do as part of that business rule needs to be distinct and on its own. So once it's finished, it's done. That's the end of that transaction. Anything that happens from that point on is part of some other transaction. It's part of some other part of the system doing something. So the decision or the business rule needs to be based solely on the information that it has at that moment in time, whether that's from the incoming command or whether it's from the current state of the aggregate itself. We should have lots of small aggregates rather than a few big ones. It's probably quite a bit of a smell if you've only got one aggregate in the whole of your service, for example. You should reference other aggregates by ID fields because of the transactional boundary. That's the only way that you have of referring to them, is purely by ID. Aggregates, you can have multiple aggregates that are interested in the same events. So what distinguishes them is their own internal logic and how they and the business rules that the business methods that they expose. So again, going back to the transactional boundary, you can split up your logic into separate aggregates, all working on the same event stream, so long as they only deal with the information that they gather as part of the events that they are interested in. failures in the command handler in the aggregate should be dealt with by generating events, business events, because they're part of the business domain model, and they're probably needed by the UI. And lastly, do keep the snapshot serialization ID updated whenever you make a backwards incompatible change of either the aggregate or a dependent class. The don'ts. So don't create CRUD commands. So we're dealing with a CQRS system and events event streams. We don't need to have create, update and delete commands for everything. In fact, it makes it harder for us to do what we want, because as soon as we have commands that say create this or update this or delete that, then you're immediately in a position where it matters what order things happen in. If we take advantage of the fact that our system is eventually consistent, we can model our events and model our commands so that they can happen in other orders. So a concrete example would be if we are creating a new user. When we create a user, we don't have to create the user before we set the fields on it. So we can issue a command to set the fields on the user rather than issuing a command to create it. And then the aggregate for the user can decide, is this the first event? Is this the first time I've seen this user? If it is, then I'll issue a user created event, and I'll issue an event to say that I'm setting the fields to these values. So we can do that modeling of that business event of the user being created in the aggregate, but we don't have to model it as the command. That's the second point as well, is making them unnecessarily dependent on ordering. So there are an awful lot of commands that probably we have at the moment and that could be refactored, and also events that really, from a business perspective, the order that they happen in isn't really part of the business rules. And in actual fact, it would be perfectly valid to model the business domain without enforcing that ordering. If information can legitimately come in a different order to the way that it will habitually come in, then maybe from an aggregate and an event perspective, it doesn't matter whether it comes in one order or another. So don't model the events and commands to enforce that ordering if you don't need to. Don't throw exceptions for failures. And it's very concrete reason for that is that if you do, they won't be caught by anything. It'll roll back and roll back the transaction, and it will then retry that particular command, and therefore it will eventually end up on the dead letter queue because nothing will have changed every time it fails. So if something is guaranteed to fail, then you need to explicitly handle it so that it doesn't get retried again. Don't reference other aggregates except by IDs because they are transactional boundaries. Use inheritance to share functionality across aggregates. Sorry, don't use inheritance.
Exceptions, Chair.
Sorry?
Exception handling for the failure scenarios.
Yes.
Because some file operations are forced to handle IO exceptions, right? So if those things happen, so what do you want to do?
Well, we shouldn't really be having any code in any of our services that have I/O exceptions unless they're actually dealing with I/O operations. So that probably suggests that that code needs to be refactored.
The reason is, yes, you're doing a CSV parts of the file stuff.
So dealing with files would be a special case, and the problem that we have there in that area is that we're not following the file handling pattern that we need to follow in order to support file handling within our architecture. So that problem will go away once we have the file service and handle binary files correctly.
When I'm creating a file also, that's the file handling coming in, and I'm trying to create a file using an API, but I still have this functionality.
So specifically here we're talking about the area around command handlers. If we have if we're trying to create a file, that wouldn't be happening in the command handler. It would be happening in the event processor, and that has the ability to deal with failures. But again, in that situation, you definitely have to catch the error and figure out what to do about it. And that may be, for example, issuing an event to say, I couldn't create the file, somebody needs to deal with it. What haven't we covered? Don't put business logic such as workflow in the command handlers. The command handler's role itself is to translate between the incoming command and then orchestrate the services that you need to use in order to perform the action that's being taken. If there's any business logic in that, then it needs to be moved and put into your aggregates, because that's where the business rules need to sit. Don't create POJOs for your commands, because you don't need them. Everything you need for a command is in the JSON object payload that you got given. So converting it into a command is unnecessary. However, you should be converting it into a representation of the data that you need in order to call your business methods on your aggregates. So you will do some conversion, but it shouldn't be to convert it into command POJOs. They're unnecessary, and it's just an extra class to have bugs in and an extra class to test. Don't reuse POJOs or domain objects across responsibility boundaries. So commands, aggregates, events and views are all separate in this sense. So when you do convert an incoming command and then call a business method, we shouldn't be passing the command straight into the aggregate. We should be converting and extracting the information from that command and then passing it to the aggregate in a way that it understands. Likewise, when we create an event within an aggregate, we shouldn't be reusing the data structures that we use within the aggregate. We should have data structures that are specific for the events, because they should only be used by the events. They're not part of the aggregate, they're part of the events, so we shouldn't be reusing them. Same goes for views. In the view store or the query, in the event listener or the query view, we shouldn't ever be seeing domain classes that we're using in the command pillar, because that means that we're sharing code across the two pillars that is completely unrelated, and changes in one area would impact the other when they shouldn't do. Don't extend transactions across contexts. So that's kind of an extension of the other points that we mentioned around transaction boundaries. We have to remember that once a message is on a queue, that's it. It's out of our control now. Listeners, processors, queries and views.
David, sorry, Sue's
Oh, sorry.
David, regarding domain objects,
Yes.
when do we have common domain objects? Like, you said usually the domain objects will be created based on the boundaries, right? So why we have separate nice domain projects?
So if you start from the lowest point, which is probably the events. So if you imagine events exist regardless of what aggregates raised them. So events know about the data structures that they use. So you may have objects that represent parts of events, for example. That's reasonable. So events should know about those objects, right? Aggregates need to be able to create new events. So they need to know how to create those events. So they need to know about the events and any associated objects that they use. But the events shouldn't know anything about the aggregates, because that's the direction of the dependency there. The command handlers are responsible for calling methods on the aggregates, and they should know about commands. So they have to know about both commands and their data structures, and they also need to know about the business methods that they call on the aggregates. But again, the opposite shouldn't be true. The aggregate should know nothing about the commands that the command handler is dealing with. So there should be no dependency up in that direction. So far we've got domain objects that represent parts of events, and domain objects that represent parts of aggregates, and our command handlers that have to deal with that translation. So there's a strict hierarchy there of who should know about what. On the query side, that side should never ever know about aggregates. Therefore, it should never know about the parts of aggregates and the bits that make them up. The event listeners need to know about events, but they don't really need to have the event POJOs directly that we're using as part of the domain model, because when you listen to an event, you get all of the data in the event as part of a JSON object. So if you start sharing the event objects and their domain objects as, across the two, then you're introducing a dependency between the query side and the command side that is completely unnecessary. There's no need to convert that incoming JSON payload back into an event, because you've already got all the data in a form that you understand and can access. Okay. So, do's for this lot. Use listeners to update view tables based on private events from their own context. So that's basically saying event listeners should only be using the data that they get out of private events to update the view store. They shouldn't be using any other information they get from any other context. They shouldn't be using any other information that they get, that they make up themselves. So they should never generate IDs. They should never generate dates. They should always use just the information that they get from the private events. And the reason for that is that we need our views to be reproducible. So if we wipe a view store, run the event stream into it, wipe it again, run it in again, we expect the data in the view store to be exactly the same. Only listen to event processors to listen to public events. Again, I've covered that off before, but I'll reiterate. That's because public events are ephemeral, they happen once. So event processors are the only things that have state that know whether or not they dealt with an event. Therefore, they're the only ones that should listen to public events.
Sorry, are they not the translator for private events also?
Sorry,
Event processors, are they not the translator for private events also?
yes, they are also allowed to listen to private events as well. Yes. Yes. Yeah. So this is a bit ambiguous. It doesn't mean only use them to do this. It means nothing else should do this.
Nothing else should listen to public events.
Exactly, yes. Thank you. Same goes for the next one, which is saying that we shouldn't be issuing commands or public events from any other place except the event processors. Do name your queries correctly. So the action name for a query should be the name of the query that you're issuing, not the name of the response. So if you've got a query endpoint that returns a set of users, then your query action may well be get users, and your response media type might be users because you're returning users. But the query name is get users, not users. Do normalize your view tables. Hopefully that's a self-explanatory one. Qualified by the point below about primary keys and foreign keys that we've talked about already. And also we've talked about the last one there. Make sure we're adding indexes to view stores as well, because otherwise they're going to suck when we hit production. So don't listen to private events from another context. Don't include any data inside a view which cannot be replayed from the view store. We've said that already. Don't generate its own data. Don't raise public events on a private event topic. So we need to make the distinction and be clear on the fact that private events only go onto the private context-specific topics. Public events only go onto the public events topic. Don't use a lot of referential integrity on the view tables. We've covered that already. Just to be clear again, because if we throw an exception and reject an event, everything will come to a halt on that view. Don't create value objects unnecessarily. Just use the JSON objects you've got in your payload already. Same goes for the query side. When you're returning responses, there's no need to convert your JPA entities into value objects. You can just extract them build a JSON object and set that as the payload of your
So-
response.
I would like to challenge this from the listener's perspective because I believe when we don't actually use value objects, it leads to ugly code in test and ugly code in listener, because what people are doing is they are having this gets against JSON objects with strings, and the strings are externalized. So instead of like 2 lines of code, when you actually use converter to convert from JSON object to your POJO, and then use getters to get the values you need, you have got like 30 lines of code, including constants. That's what I observed just here.
So I think the counter argument against that is that by creating those value objects and creating an automatic conversion, we're introducing the potential for unnoticed defects and exposing information that we don't want to. Whereas if we are explicit about the fields that we are extracting and putting into our responses and putting into our...
I agree with responses, but this is particular about the event listener. So on event listener level, we already need this connection with the event itself.
Right.
So why not just
okay.
go
So there is so in the event listeners, that is an interesting special case in the sense that you're consuming exactly the same events that you're emitting on the other side of the fence. So the question around sharing POJOs at that level and sharing code is at that stage is a what's the word I want? It's a theoretical argument as to what's right in terms of what you should be sharing. One thing that we are missing at the moment is tooling around events, in that we have JSON schemas that define events, but we also have Java POJOs to represent those events, and it's a manual task to keep those two in sync. If we had tooling that would generate our event POJOs from our JSON schemas, then we would have a mechanism to automate those two things. And that would give us the ability to keep the separation between the query and the command side of things, and instead generate those POJOs on both sides of the fence from the same JSON schemas. And that would provide us the best of both worlds. And that's probably something that will happen in the near future.
Is that on
It's always easy to use it like there is a nested JSON, right? The view is what suspects is what something else.
Yeah.
It's really difficult to they get suspect dealing with the JSON rather than with the
If you call it
objects.
it's a view rather than value object, because the front end sometimes asks that we want the data this way because it could be handled better. If we start giving them flat objects, it's not good for them, so they want it.
I'm not necessarily saying that you want flat objects, but you can make nested JSON manually without having a POJO in the middle of it. Well, it's just as time consuming to write a load of POJOs and write the unit tests for them. So it's a question of where you want to put the effort.
Is there a tolerance issue with this as well? Because once we go live, some events will change. If you're
Yep.
using value objects,
Exactly.
does
There's
that make it
yes.
more brittle?
Exactly. So there is a brittleness issue and backwards compatibility issue in that being more explicit about that conversion process means that you're being very clear on what you're expecting to get in a certain thing. You're not going to be affected if something stops being in there unless you've got an explicit rule around it. You're not going to have an IO exception from Jackson because it can no longer convert your POJO from an old event. You can write your unit tests to test the behavior of the class and reason about it based on exactly what's in the code rather than on the serialization and deserialization features provided by Jackson.
And maybe that point could go on maybe do it, maybe not do it. I mean, you do say unnecessarily.
Yeah, absolutely. All of this is a judgment call, and it's all about weighing up the pros and cons. But when I do feel that when you weigh up things like handling Jackson IO exceptions and being explicit about it, dealing with missing fields and that sort of stuff, it's all the more explicit you are about it in your code, the clearer it is as to how you expect it to behave. Whereas relying on behavior that's hidden away in a library that isn't strictly speaking intended to be used for this purpose is a bit weird, particularly when it's introducing extra code for you to test. We do have some helper methods around extracting nested fields from JSON objects as well. And if there's other stuff that we need that can make the code cleaner and easier to work with, then you know, we can come up with ways of wrapping it up and doing it.
Isn't that
Usually, even as part of the even as part of the private event, we are just publishing the minimum information that needed. I mean, we are not, you know.
Well, the private event should
you said,
contain
okay,
all of.
Like something changes, right? And then you can't make the object out of it, right? But usually, we say like if I'm authorizing a proposed charge, what I'm just publishing is just the proposed charge ID, because I'm just authorizing an existing proposed charge. So it's not that I'm emitting the whole thing. And you know, as part of the private event, which I generate, is the minimum thing which I think I will need on that side. Those are the only ones I'm exposing.
Well, no, the private events contain everything that's needed for that particular state change.
Yeah.
So it's not about a minimum in that sense, but you need to consider that those private events are consumed by the event processor and the event listener for different purposes, and therefore you may make changes to what goes into those private events for the benefit of just one of those two components and not the other. And if you're sharing the event, if you're sharing the two, then you're basically sharing those POJOs across both of those classes. At some point in the future, we may well want to be able to release service components on their own, so we only want to release the event processor on its own, and we wouldn't want to have to release the event listener just because otherwise it's going to break.
I think there's a more general point there as well. You shouldn't be filtering out information. I've seen this happen in the code, filtering out information from commands so that you're restricting down to just what you need presently for your events, because you don't know what other services and things that are going to come along. If you don't persist the information that comes to the command as an event, then it's lost to the system, and you never know when someone's going to have another service and actually it does make these fields.
It is. So that's a related but slightly different point, which we should probably put in the don'ts list for the other one. So general do's and don'ts. Make sure your services return only appropriate data to the UI. So if you're writing a query endpoint that returns case data, we shouldn't just arbitrarily just add in everything that we've got in our view store. We should only add in the things that the UI actually needs at this stage. It may be that in the future you need to extend that endpoint to add additional information in, but if we start from exposing everything, then that makes access control a lot harder in the future, and we'll have to do more refactoring around what query endpoints we provide and what responses we provide. Avoid using words like command, query, and event in class names and in action names for the for those messages. They shouldn't be necessary. It should be clear from the name what the thing is. So it should be clear from the tense, whether it's imperative, whether it's past tense, or whether it describes a query. It should be very clear from the name. So we shouldn't need to add command or query or event into either the action name or the class name. Make sure we're using framework tools wherever possible, such as the enveloper, to propagate the metadata. Same goes for other things. If you're doing something that seems like it ought to be supported by the framework, it probably, or made easier by the framework, it probably either already is or it ought to be, and therefore should talk to us and talk about adding something or enhancing the framework to do that. Simply so that it can be done in a consistent way, because if you've hit an issue, then it's likely that somebody else has somewhere else, and that they should be doing it in the same way that you are. Use standard framework data types and utilities, such as for dates. So that's a very important area where we need to make sure that we're using the framework components for formatting dates and parsing dates. Make sure that we're always using the correct data types, using zoned date times to represent date times, because if we don't, then we run the risk of introducing date-related bugs and formatting incompatibilities between services. Do identify code that can be reused and refactored into the framework or our other library components. Always look out for opportunities to reuse and contribute and make somebody else's life easier. So stop before you cut and paste. Do extract reusable Maven configuration into parent POMs. If you're using a new library that isn't in the common BOM, for example, which you think other people should be using as well, then raise that as a change to the common BOM and get that merged in so that everyone can use it, know that it's there, and that it's, we're using a consistent version of it across everything. Do keep your RAML files as simple as they can be at this stage. So there's no need to put a version number into the RAML because we're not doing versioning of services. We're not planning to do it using RAML versions in the RAML file. We're planning to do it as version numbers in the events and queries, in the query names. So don't put stuff like that in there. There's no need to put traits in there, for example. They're not being used for anything. They're just extra stuff to cut and paste and move around. And also response codes. There's no need to put any response codes in except for the 200 response code for queries. It's just extra noise. At some stage in the future, I strongly suspect that we'll have some tooling around post-processing RAML, and at that stage we can add this sort of thing in automatically. So at this stage, it's just adding extra work. Do ensure your code meets SonarQube compliance guidelines, such as 80% code coverage and no major issues. It's worth checking that after you've pushed some code in, or even before, just to make sure that you go and tidy up and don't incur more technical debt. Do use the file service when it's available for unstructured data. Not a lot you can do about that at the moment, but bear it in mind. And do think about your access control rules with your business stakeholders as part of the domain model. So access control is really part of the domain model, so it needs to be considered as such. And it's worth thinking about it as a developer as a holistic thing along with the rest of the domain model, and questioning why the rules are being put in place and how those should be modelled as part of the domain. So, for example, don't think about things necessarily as a technical implementation. So, for example, users and groups. Thinking about whether a user is in a particular group is a technical way of solving a particular access control rule. But in actual fact, it may be that if we talk it through with the business, it may be that actually there is a business model for that doesn't involve users and groups. It may be that actually the question is, does the user perform this particular role within this particular organisation, and at which stage the access rule becomes slightly more complicated, but it can be implemented in a way that more accurately represents the business model, the domain model. Don't use version numbers and dependencies in Project Maven POMs. We have dependency management imported as part of the service parent POM and the library parent POMs. For external libraries, we should always be using the versions from there, so we should never be overriding them within our POMs. If you see a version, delete it, and if Maven complains because it's missing a version, then the version of that library now needs to go into the common BOM so that it can be used across the rest of the program consistently. The only version numbers we should have within our service POMs are for our own dependencies from context to context. So dependencies within a context or within a service should use project.version as the version number. For dependencies on other contexts, so for pulling in the RAML, for example, then we should have properties defined at the top level of the project, and then those get used within the dependencies when you're pulling in the RAML that you're depending on. Don't load data into tables via Liquibase, because it's non-reproducible. If we wipe the data out of the view store and replay the events, it won't be there. And it's also you can't reason about it as part of the event listeners. You can't reuse that data as part of the rest of the service. So data that needs to be seeded into context should be seeded via issuing commands to the service instead. Another one around the file service, which we don't have yet, but once we have it, we shouldn't be persisting unstructured data via commands into event stores. Not only is that going to be a performance hiccup as massive amounts of data flow through our JMS queues, but also we're going to end up with bloated event stores that have a load of stuff in there that shouldn't be in there. The last one is a big one. Don't have your handlers extend a superclass or use converters, generators or factories to improve or make the code look more elegant, because it hides what the handler is doing, it makes it brittle, it creates the necessity for additional tests, and it's just unnecessary. The whole principle behind the framework, as I mentioned right at the start, was that the framework is around composable services, and the handlers should explicitly define the business logic that they are implementing and compose those services. So as soon as we complicate those handlers with a whole load of other nice patterns, although they seem nice in terms of responsibility segregation and following all of the patterns that we use elsewhere, what they actually do instead is hide what is the fundamental purpose of a handler behind a load of abstractions. They make the code more brittle when we want to make changes that don't fit into that particular refactoring. Then we end up having to refactor a whole load of code that we shouldn't have to, when instead we probably could have got away with just refactoring a single handler. And we end up having a whole load of additional unit tests that we don't strictly need, because we now have to have unit tests for those factories and generators and converters, and we have to have unit tests for our handlers that are effectively just testing a bunch of wiring. So I'm aware of the fact that in handlers, particularly in command handlers, the unit testing of those is difficult because of our injected components and how they interact. But we can do the testing of that instead using concrete dependencies or some of our test utility helpers instead. So it should be possible to write behavior tests for our handlers that are essentially testing, if I give it this command, do I get these events appended to the event source? It should be possible to write those tests pretty clearly if we use the right level of mocks and helpers in order to do that. So if anyone hits any issues with trying to use that approach, please come and discuss it with us so that we can figure out whether we need to add more helpers into the test utils libraries, or how we can go about making that easier, because it will help us in the long term if we do that.
A quick one on my test. Is it okay to use a YMOC unit test? Sometimes if you want to set up paragraph services and engine something, just using mock is quite difficult.
So is it okay to use YMOC within a unit test? I don't see why you would ever need to, because the only calls that we make out to external services are done via framework components, which can be mocked themselves using Mockito.
Yeah, I mean, sometimes Mockito is quite difficult because you want to pass the JSON to return this based on something just set up. Just time, yes, it's doable.
It's probably faster than using.
No, it's quite easy because you can load you can return a JSON, you can have a JSON file return it with this URL that you use.
I think it sounds as though what you've got there is not a unit test then.
Yeah, that's it. But it's too easy unit testing. It's just easier.
Let's look at specific examples offline, because I don't know, it depends on what you're trying to test. But no, as a general rule, I would say probably that's a smell that your tests aren't decomposed in the right way.
David, many points I have seen this base command handler concept, like where we have moved the center injection.
Yeah.
Because most of the handlers method, a handler is doing nothing but center dot set.
So
So this injection depends on why don't we just move it to base command handler and all handlers will have that sender?
Because we don't want to have a standard and default behavior for every handler, because as we go on in time and the code base gets more mature and we deal with the architectural patterns more consistently and correctly, we will find that there will be more and more examples where our handlers are not straight pass-throughs, and by hiding away the fact and making it not explicit that that's what they're doing at the moment, it'll just mean that we have to refactor again at some point in the future.
No, it's not about how composing string, it's
Mm.
about sending the string. So you have sender.send.
Yeah.
So which is like kind of the standard. Like how you're composing is the functionality.
So it's not standard. So the fact that we happen to be doing that in a lot of places is happenstance to how people have written that code. It's not necessarily the way that every handler should be doing things. In fact, it's probably a smell of our more complicated domains that we are doing that in every single handle method. That probably indicates that probably we have created our aggregates and our events so that there is a one-to-one mapping between commands and what they're doing to the aggregate, when in actual fact there shouldn't be.
Give an example. So can you give an example? I'm trying to relate.
So an aggregate's, no, I can't give you a concrete example without pulling up some code, so we should probably take that offline. But as a general principle, because the command handler is supposed to be translating between commands and business methods on the aggregate shouldn't know about the commands. Therefore, if there is always a one-to-one mapping between the command, the aggregate business method and the event, that is particularly for complicated aggregates, that is probably a smell that the model that's been chosen is wrong. Doesn't necessarily mean that it is wrong, but it probably is. And like I say, the test utility helpers that we have or ought to have should make the testing of this sort of thing easy to do as behavior-driven tests. And as soon as we refactor the behavior of each of those command handlers so that they're using a common superclass, it means that as soon as one of them wants to do something differently, then it's it's the odd one out, and you start to have to refactor in order to make it work properly.
I think that might be true between the controller and handler layer. A lot of the stuff that's happening from the API to the controller is behavior.
I think I thought we were just talking about the command handlers specifically. So in terms of translating down the layers, that's a different question. And again, there's probably a case to be made that the transition between some layers probably shouldn't be the same.
It just seems like it's a broad stick to say for people behind that. It just seems to be a broad thing just to say that most coherency is always correct. I think that's sometimes you do need shared behaviour across.
I'm not convinced that I've seen any examples where it's adding value. Okay, well that's the end. It's 49 slides, not 50. If anybody has any last questions.
Is there going to be a similar session after we go live? Because it's pretty much a certainty that we're dealing with a much different beast once this thing goes live. The behaviour we're going to have to change and things like that. I mean, are there forward-thinking considerations around things like that?
That's a good question, and yes, we should probably do something around there. Feel free to start making notes on what you think the issues are.
Once we go live, I mean, it becomes much more difficult to write code for this platform.
It does. Following these do's and don'ts will help us to make it easier, for sure.
These do's and don'ts, I mean, it looks like they had been there for 5 months or something. But I think even these have evolved over time, or they were very clear, because we are seeing it.
No, so
quite a few of them.
to be very clear, these do's and don'ts have been compiled recently, based partly on just general thinking about where we've got to in terms of our thinking, and partly on reviews of code and figuring out what works and what doesn't. So it shouldn't be considered as a criticism that we're doing a lot of the don'ts at the moment. It's the fact that we're doing a lot of the don'ts at the moment that's meant that we've been able to compose the list so that we can do better in future. So it's where we are. It's not a this isn't supposed to be a set of criticisms and a telling off session. It's a question of these are the things that we've picked up so far that means that we can improve the code base and make better coding decisions in the future, which is a positive thing. Okay, well, thanks everybody for sticking with us, and see you at the next one.